Hello everyone. Today we will be studying in computer graphics the 2D transformations. What is 2D transformations or what is transformations? It is the changes in orientation, size and shape which is accomplished for the geometrical transformations that alter the coordinate descriptions of objects. So we need to shift the object, we need to change the size, or we need to change the shape of the object and also the orientation from one place to another. Why is a transformation needed? It is needed to manipulate the initially created object and to display the modified object without having to redraw it. So we just need to move it from one place to another and we do not need to redraw it again. Basic 2D transformations. Today we will be studying about three basic types of transformations: translation, rotation and scaling. Although there are higher transformations also, reflection and shear, but in today's class we will be discussing only about these three 2D transformations. Starting off with translation, what is translation? It is repositioning an object along a straight line path from one coordinate location to another. This simply means that here in this what we do is that we have this point and we wish to move this point from here to here. This is known as translation, moving the object from here to this position. This is known as a translation. A translation moves all points in an object along the same straight line path to new positions. That means our object's shape is not changed, only its position is changed. The path is represented by a vector called the translation or the shift vector. We have this point, the blue dot, which we are trying to reposition at this point, which is denoted with a red point. So for moving this point, we in the x direction we are moving a distance of tx, which is known as the translation or the shift vector in the x direction, and in the y direction we are moving ty, which is known as the translation of shift vector in the y direction. So that means if we have this point 2, 2 and we need to move it to this red point, so we are moving in the x direction by 6 units and in the y direction by 4 units. So this point changes, which we can calculate from here. P dash x, that is this new point, the x coordinate of this new point equals to px, the old x coordinate, plus the translation vector in the x direction. That is 2 plus 6, that gives us 8. So our p dash x becomes 8 and p dash y equals to, that is the new y coordinate of this point equals to py original y coordinate, that is 2 in our case, plus ty, the translation vector in the y direction, which is given as 4. So it will be 2 plus 4, that is 6. So the new coordinates become 8, 6. We can also write it in the matrix form, p dash equals to p plus t. The new coordinates can be calculated by adding up the old coordinates with the translation vector tx and ty. Moving on to rotation. A rotation repositions all points in an object along a circular path in the plane centered at the pivot point. This is a pivot point 0, 0. So we will assume the pivot is at 0 and we will move our P point anti-clockwise to the new P dash point. Now for this we need to revise a trigonometry. Suppose the original point is P, x, y. So what here we do is this x comma y is at an angle of phi from the x axis. So our cos phi equals to x upon r, that is the base upon hypotenuse, and sin phi equals to y upon r, which is the height upon hypotenuse. So this can be rewritten as x equals to r cos phi and y equals to r sin phi. Now we wish to move this position P by an angle of theta to a new location P dash given by x dash comma y dash. So here if you see, this is theta and this is phi. So what we do is, now to calculate this position we have to take the full angle phi plus theta. So cos phi plus theta equals to x dash upon r. The r remains the same. So x dash equals to r cos phi plus theta. X dash, this can be opened up like this. Here what we do is, these are the identity of trigonometry. Similarly, sin phi plus theta equal to y dash by r, and this can be rewritten as y dash equals to r sin phi plus theta, and y equals to r cos phi sin theta plus r sin phi cos theta. Now we will make a little amendment here. Here x equal to r cos phi. So in this x dash, r cos phi can be replaced with this x, and r sin phi can be replaced by y. Similarly, the same can be done here in this also. So our equation actually changes. R cos phi, we put x, so it becomes x cos phi minus r sin phi is replaced by y sin theta. Similarly here it becomes x sin theta plus y cos theta. Now we can write the components as, since we want this new position P dash, so P dash x can be calculated as the original x coordinate px cos theta minus py sin theta. Similarly, P dash y equals to Px sin theta plus Py cos theta. In the matrix forms, we can write it as R dot P. Now this theta, we need to be careful with this theta. If we are moving in the counterclockwise direction, this theta needs to be positive. But if we are moving in the clockwise direction, then we take theta as negative. And this is our rotation matrix, which we get from this equation: cos theta minus sin theta, cos theta. Here all we need to do is multiply this with P dash x and Px and Py to get our new coordinates. This can be explained through an example. Find the transformed point P dash caused by rotating P equal to 5, 1 about the origin through an angle of 90 degree. So we know that cos theta, this is a rotation matrix, and this is our original coordinates, which will give us this matrix. All we need to do is substitute the values. The x is 5 and y is 1. So we substitute x by 1 and y by x by 5 and y by 1, and theta is replaced by 90 degree. And when we calculate this, we get a new position minus 1, 5. Now the last thing is scaling. Scaling changes the size of an object and involves two scale factors, Sx and Sy, for the x and y coordinates respectively. Scales are about the origin, and for scaling all you need to do is multiply the original x with the Sx factor and original y with the Sy factor, which we can represent in the matrix form as S dot P. So we have this triangle which can be scaled to a new position P dash. So our triangle, the size of the triangle gets increased. Now if the scale factors are between 0 and 1, the points will be moved closer to the origin, which we can see from this diagram. Moving this side, the object becomes smaller. As an example, if we calculate the new p dash for this p, this is how we can multiply and get it. Now if the scale factors are larger than 1, the points will be moved away from the origin and the object will become larger, which is depicted through this diagram. And this is the example where point 2, 5 is to be scaled by 2 units, and you need to find p dash. If the scale factors are same, we have uniform scaling, only the size changes. But if we have differential scaling means different x and different y as xy, then in that case, along with the size, the shape of the object also changes. So the square is generally changed into a rectangle. These are the questions which you need to attempt before coming over to your class. Thank you.